Welcome to Chapter 4, Part 7. We're going to talk about the absolute value function in this section. We're going to skip example problem 99 and go on to 100. You'll come back, though, and do problem 99 after we've looked at how to do these problems. Okay, we're going to look at an example of how to graph absolute value functions. In this problem, it is y equals the absolute value of 2x minus 1. Minus 1. So if we plug in negative 5, 2 times negative 5, take away 1. So we get the absolute value of negative 10, take away 1, which equals the absolute value of negative 11, which equals 11. If we do negative 4, we have the absolute value of 2 times negative 4, take away 1, which is negative 8, take away 1, which equals the absolute value of negative 9, which is 9. If we do negative 3, y equals the absolute value of 2 times negative 3, take away 1. So negative 6, take away 1. Absolute value of negative 7, which equals 7. Absolute value of 2 times negative 2, take away 1. Equals the absolute value of negative 4, take away 1, over the absolute value of negative 5, which equals 5. The absolute value of 2 times negative 1, take away 1. So absolute value of negative 2, take away 1, which is negative 3. The absolute value of negative 3 is 3. And we keep going. Absolute value of 2 times 0, take away 1, gives you the absolute value of negative 1, which is 1, because 2 times 0 would be 0, minus 1 is negative 1. Absolute value of 2 times 1, take away 1. Absolute value of 2 minus 1, which is the absolute value of 1. And that's just 1. So we're starting to see our symmetry. So absolute value of 2 times 2, take away 1. Absolute value of 4 minus 1. Or the absolute value of 3, which is 3. And so we start to be able to see, we've got 1, 1, 3, 3. So next will be 5, 5, 7, 7, 9, 9. And we should get those values if we plug in 3, 4, and 5. So once again, this is the absolute value function we know because of those vertical bars around the 2x minus 1. And the x-intercept is where y equals 0. Now we don't see it, but we can see that it's probably right in between here because we go down to 1 and then we start going back up. So right in the middle would be 1/2. So if x equals 1/2, let's see what we get for y. So y would equal 2 times 1/2 minus 1, all in absolute value. Well, half of 2 is 1. Take away 1 is 0, and the absolute value of 0 is 0. So the x-intercept is going to be right in the middle here. It's going to be the point 1/2, comma 0. The y-intercept is the value where x equals 0, which is this one right here at 0, 1. The special point of the vertex is the point about which the symmetry builds. So that is also the x-intercept in this case. It's not always, but it is in this one. So right here is the vertex, because then out from there we go 1, 1, 3, 3, 5, 5, 7, 7, 9, 9, etc. So the vertex is 1/2, comma 0. Let's graph it. So negative 5, 11, I don't think it's going to fit. Let's see if negative 4, 9 does. Nope. But we can do negative 3, 7. And negative 2 comes down to 5. Negative 1 is at 3. 0 is at 1. 1/2 is at 0. 2, 1. 3, 5. 0.4759. Oops. Let's try that side again. Okay, so there's the graph of that one. Is it a function? Yes, it passes the vertical line test. Every input has one output. So let's think about the domain and range of this graph. Again, you've got arrows on the left and right side, meaning your domain is all real numbers. We can plug in any x value we want. The graph will continue to expand from left to right forever. The range, we can see a lowest point here, and then it continues all the way up with arrows on the top, so all y values 0 and larger. So 0 is less than or equal to y, which is less than infinity. Again, we can do the equal to with the 0 because we legitimately use that value. We have a point on 0. Infinity we can never equal, so it always gets the rounded parenthesis and doesn't have the equal to line. All real numbers means everything from negative infinity to infinity. Again, can't equal them, and we use the rounded parentheses. Okay, so on our graph, what are the x values for when y equals 5? Well, if we count up to 5 on the y-axis, and we can draw a line, we see 2 points, one right here and one right here. So when x equals -2 or x equals 3, y equals 5. Both of those x values, when you double them, subtract 1, and take the absolute value, you'll end up with 5. So let's see how to get that with the equation. So when does the absolute value of 2x minus 1 equal 5? Well, we have to consider two possibilities. With absolute value, the thing inside could be positive, because the absolute value of positive 5 would give us 5. Or it could be negative 5, because the absolute value of negative 5 would still give us 5 once we took the absolute value. So we consider those two equations. So we see that 2x, oops, this one was my negative one, so 2x could equal 6 in the positive case, or negative 4 in the negative case. So let me bring these over so I have some space. So x equals 3, or x equals -2. Just as I found on my graph. So what you'll find is absolute value always has two solutions. Unless, of course, you get the absolute value of 0, and then that's your special case with only one answer. Or if absolute value equal to negative, because we know that's just plain not true. Absolute value always comes out positive. So here's some more about how to solve absolute value equations. Remember that absolute value represents the distance a number is from 0 on the number line. Since absolute value is a distance, the result of finding an absolute value is 0 or a positive number. All distances are positive. So when you take the absolute value, you'll never get a negative answer. Here's our first example. The absolute value of 2x plus 3 equals 7. So 2x plus 3 could really equal 7, because if I had the absolute value of 7, I would get 7. 2x plus 3 could also equal -7. Because if we take the absolute value of -7, we'll still get 7. So you recognize that whatever's inside the absolute value could equal the positive or the negative of the constant that it's supposed to equal. Do not ever change the sign inside the absolute value. You have to consider that this whole expression could be positive 7 because the absolute value of 7 is 7, or it could be negative 7 because the absolute value of negative 7 still equals 7. So then we just solve the two equations. And we see that x could equal 2, or x could equal negative 5. In our second example, we need to do one step before we can split into two equations. We have to get rid of that leading coefficient, and because there's no operation symbol between the 2 and the absolute value, I know that means multiplication. So the opposite is to divide. So that's the first thing I have to do. I have to get the absolute value by itself before I can take it and split into my two equations. So anything outside, like a coefficient here, or if we're adding or subtracting anything back here, that has to disappear before I split. So for this one, I divide both sides by 2, and I get the absolute value of 2x plus 13 equals 5. And now I'm ready to split into two equations. 2x plus 13 could equal 5, or 2x plus 13 could equal negative 5, because the absolute value of 5 gives me 5, but the absolute value of negative 5 also gives me 5. So it should be the exact same solution steps to solve both equations. If it's not the same solution steps, stop and check you've done something wrong. And so we get that x could equal negative 4, or x could equal negative 9. And that's how we go about solving absolute value equations. You want to get rid of anything outside the absolute value prior to the equal sign. And then once you've gotten rid of that and you just have the absolute value equals, you're going to split into your two cases. And consider that whatever's inside here could be the positive, because the absolute value of a positive is positive, or it could be equal to the negative, because the absolute value of a negative gives you a positive. And you should always take your two answers, plug them back in, and make sure that they really work out. So if we do that quickly for the second one, if we do 2 times the absolute value of 2 times negative 4 plus 13, we get 2 times the absolute value of negative 8 plus 13, or 2 times the absolute value of 5. The absolute value of 5 is 5. 2 times 5 gives us 10, which is what we were supposed to get. We can also check the negative 9. 2 times the absolute value of 2 times negative 9 plus 13. Well, the absolute value of negative 9 is negative 18. Negative 18 plus 13 is negative 5. The absolute value of negative 5 is 5. We get 10, so it checks. Remember, absolute value of any number always comes out positive, and we expect to get two solutions when we're solving an absolute value equation.